Hi everybody, I'm gonna talk now about Multisim. First, when you first open the Multisim, it will show this window. From this window, right up here, you will find place source, place basic element, place diode, transistor, analog, and so on and so forth. So from this menu, you can add any element you want to the circuit. This menu here contains multimeters, function generator, wattmeter, oscilloscope, 4-channel oscilloscope, baud plotter, frequency counter, word generator, logic converter, and so many meter devices, measurement probe, current probe. This can be connected to the different oscilloscope types, and Tektronix oscilloscope. These measurement devices and function generators and these meters in general can be added through multiple libraries, but this is the basic library installed with the Multisim. So now we will add some sources and basic elements. Let's see, we're gonna add a voltage source, DC voltage source. From power source, you can see AC power, DC power, digital ground or ground, 3-phase delta, 3-phase star. So I'm gonna add AC power. This AC power by default is sinusoidal waveform. Voltage RMS, voltage offset frequency. I'll make the frequency here 50 Hertz as in Egypt. Voltage RMS as in Egypt also 220. Okay. Then I'll add some resistor, basic elements like switches, transformers, non-ideal, RLC, relays, sockets, resistors, capacitors, inductors. So I'll add resistor 1 kilo. You can choose any value and then edit it later. 1 kilo. When we double click it, you can see you can change the resistance value from here, and tolerance, you can add the tolerance, temperature, coefficient, display. We can make it 10 kilo ohm. Okay, then we can copy it, paste here. We can then rotate it. Then we can connect the circuit elements with each other like this, and then like this. Okay, now I want to start the simulation. Starting the simulation is from this button here, run F5, or from this button, simulation switch. You can start the simulation either from here or from here. When I did press the button, it showed an error. The circuit is not grounded. Okay, so in the Multisim, you must add a ground to tell the Multisim every voltage you measured, is measured or referred to what point. You must add a ground in the circuit. Okay, we will add ground from basic power sources ground. Double click it, it will show here. After adding it, I can now run the simulation because the circuit has a ground now. Okay, run. It's running. You can notice from the bottom right corner, it's running and the timer is running here. Okay, so I'm gonna stop the simulation now. Now I want to measure the current in the circuit, the voltage over R2. Okay, so I'm gonna add two multimeters. One multimeter for the current, it showed here, multimeter. Okay, and one multimeter for the voltage over R2. When I press on the multimeter, it shows the RMS value of the current or volt or the value of ohms, and then I can choose DC or AC. DC for DC measurement and AC like this case. So I'm gonna choose AC and voltage to measure the voltage over R2. Then I connect the voltmeter in series. It's in the voltmeter mode now, so I'm connected. Sorry, I'm gonna connect the voltmeter in parallel to measure the voltage over the resistor. This ammeter to measure the current in the circuit, so I'm gonna connect it in series like this and delete this wire, so the ammeter now is connected in series with the circuit. I'll measure current and AC current. Okay, this volt and AC volt. So I'm gonna connect. I'm gonna run the simulation now. Run. Open it to see that the RMS value of the voltage is 110, almost 110, approximately 110, half the voltage of the source, because these resistors are equal. Okay, and the current is 11 milliamps. 11 milliamps. Okay, now if I'm interested in displaying the waveform, the instantaneous waveform, I'm gonna use now I'll stop the simulation first. Then I'm gonna use an oscilloscope to display the voltage over R2. Okay, so I'm gonna add Tektronix oscilloscope. The basic difference between oscilloscopes, you can get the ordinary oscilloscope and Tektronix. When you open the ordinary oscilloscope, it's just some values: channel 1, the volt per division, the position, Y position, channel 2, same, and the time per division scale. Okay, and it will display the sign here, the waveform, sine wave. Okay, but Tektronix oscilloscope, the main difference is it actually shows you the shape of oscilloscope. You can change it. You can change this by turning the wheel right, clockwise, and counterclockwise. The probes, the shape of probes. I can turn the power on and off. The actual display of an actual oscilloscope with this part number TDS2024. It's an actual oscilloscope display. So I'm gonna use Tektronix oscilloscope. I'll delete this. Okay, and it has here many probes, but G is connected to the ground of the voltage you want to display, and channel 1, on channel 1 I'll display the voltage over R2. Channel 2, on a channel 2, I'll display the total voltage or the voltage on the source. Okay, now I'm gonna run the simulation again and sure that the values is the same. The values are the same. And Tektronix, it's powered on. Channel 1, channel 2. Okay, auto set. When I press auto set, you can see on a channel 1 the voltage on R1, channel 2 the voltage on the supply. Okay, now I'm gonna set the datum, the reference or the datum of both voltage signals to the center of the screen. You can notice that channel 1 has 100 volt per division, channel 2 has 100 volt also per division. So channel 1 or the voltage over the resistor is half the voltage over the source. This is instantaneous value. If I want a single shot, I can press single shot here, and the oscilloscope acquired a single shot for 1, 2, 3, 4, 5, approximately 5 cycles from the volt. Okay, this was a quick overview for the multisim. I hope this was benefit. Okay, there was a benefit from this review. Okay, thanks all. Bye.